So the first one right here, the exponent is negative. So I'm going to make this 1 over negative 2. I'm going to make it negative 2 over 1. And I don't really have to write the 1 underneath because everything is over 1. And I could make the exponent positive. Also here, 1 over 2, I'm going to change it to 2 over 1. I don't have to write the 1 on the bottom. And change the exponent to positive. This here will be negative 2 cubed, which is negative 8, plus 2 squared, which is 4. And that will give me negative 4 as an answer. Okay. This one right here, Adam, and I knew lots of people were gonna make mistakes on this right here. So here, this 2 here, keep it where it is. This 3 to the negative 1 is gonna go to the top of the fraction. And that way the exponent becomes positive. And then we still have the negative 2 here, which gives me 2 times 3 to the 1, just 3. So 2 times 3 is 6. 6 to the negative 2. Now, this negative 2 is going to force us to change this to 1 over 6. So we could make the exponent positive. And that way we got 1 over 36. So even though we have a lot of stuff here, 5 to the power of negative 2 times 47. Anybody who's going to start working on this first and get into big numbers and stuff, they shouldn't do that because they should look at the exponents outside. The exponent outside is 0. As I said, it doesn't matter what's inside the bracket is. If the exponent outside is 0, then you end up getting 1 regardless. Okay, so that's 1. Now here we're going to get a little bit more complicated. But what you're allowed to do here, you're allowed to go 4 over. 4 to the negative 1, we don't like negative exponents, so I'm going to change it to 1 over 4. Plus, and the 4 to the power of 0 is 1, because anything to the power of 0 is 1. What do I do next? Next, I'm going to keep the 4 on top. And the 1/4 plus 1, I'm just going to put that over 1. I'm going to do a common denominator by multiplying this by 4, multiplying this by 4. So that will give me 1 plus 1 times 4 is 4. And the common denominator is 4, which gives me 4 over 5 over 4. And this here is division. Okay. So this becomes 4 divided by 5 over 4. This is 4 over 1. So we change this to 4 over 1 times, we flip this to 4 over 5. And then we end up with 16 over 5. Okay. Now let's do this one right here. And this one here, 2 to the negative 1, we're going to change that to 1 over 2 to the power of 1. And when it's to the power of 1, we don't even have to show it. This here changes to 1 over 2 squared. And this changes to 1 over 2 to the power of 3. Again, we're making the negative exponents positive by going 1 over that number. And that allows me to do that. All right. Now, this is 1/2. And 1 over 2 squared, that gives me 1 over 4 minus, and 1 over 2 cubed. 2 cubed is 8, so that's 1 over 8. Now here on the bottom, I have to do common denominator. So I have to multiply this by 2 and multiply this by 2 to make this bottom the same as this bottom. And therefore now I have 1/2 all over. 1 times 2 on top here is 2 minus 1 all over 8, which gives me 1/2 all over 1/8. Now this is, I'm just gonna throw it right here, is the same as 1/2 divided by 1/8, which is the same as 1/2 times 8 over 1. And that will reduce to give you 1, and that will reduce to give you 4. So 1 times 4 on top is 4, and you have 1 times 1 on the bottom, which is 1. When it's 1 on the bottom, you don't have to write it. So the answer for this is 4. So I'm going to do both of these questions. This is new. So if we have 3 to the power of x equals 27, and we need to solve this, then we know x must be 3, because 3 to the power of 3 is 27. However, we want you to do it without just looking at it and say, oh, okay, x equals that, because sometimes it doesn't work that way. So here, what we usually do with this kind of questions, and you'll deal with this in grade 12 again, this is 3 to the x, but the 27, what I do, I change it to 3 to the power of 3, because 27 is the same as 3 to the power of 3. Now, when we have this situation here, and both bases, we call this, the 3 here is the base, and this 3 here is the base. When the bases are the same, we could just cancel them and say, okay, x equals 3. X equals this number right here. How about here? This will be a little bit longer. This is 4 to the power of x equals 1 over 4 squared, because 16 is 4 squared. Now, can we cancel the bases? No, we can't, because this is 1 over 4 squared. It's not 4 squared. However, what we could do, we could go, okay, this is 4 to the power of x equals 4 to the power of -2. We could bring this 4 to the top and make the exponent negative. Now the bases are the same. I could cancel them, and x equals -2. So here, what you need to do to this, you need to keep this as 2 to the power of x. And this 32 on the bottom, you could change it to 2 to the power of 5. And after that, you keep this as 2 to the power of x, and you bring this 2 to the power of 5 on the bottom to the top, because that's the only way you could cancel the bases. Now you could cancel the bases, and you get x, or arrow x equals -5. How about here? Here, thanks, Adam, for bringing that to my attention. I wrote 324 somehow. But 3 to the power of x here equals 243 is 3 to the 5. And therefore, now you could just cancel the bases. This one is easy. And you get x equals 5. Now, the third one is a bit harder. So then I made this a bit challenging because in here, both of these, you have to change them. And this is an x plus 1. So what you're going to do here, the 4, you're going to change it to 2 to the power of 2. And you still have the x besides here. Okay, so 2 to the power of 2x. Or if you wish, I could just write it as 2 to the power of 2 inside the brackets, and I put an x here, if that looks better for you. And this here is going to be 2, the 8 is 2 to the power of 3. So why I have to make both of these the same base? The 8, I cannot change the 8 to 4 to the power of something. 4 to the power of something gives you 8. It's not as obvious. And that's why we went to a lower base, which is the 2, and I made both of these 2 to the power of something. And then at least our bases here become the same. Okay. And I have the x plus 1 here. Okay. Now this will give me 2 to the power of 2x, because you multiply the exponent outside the brackets and the exponent inside the brackets, equals 2, and you multiply the exponent outside of the brackets and the exponent inside the brackets. So I'm just gonna, you know what I'm gonna do? I'm just gonna do this in steps. So I'm gonna go 3 times x plus 1. Now, since the bases are the same, I could cancel the bases. And this becomes an algebraic expression, which is 2x equals, and I'm gonna distribute the 3 into the x and to the 1. So you're gonna get 3x plus 3. Okay, now I'm gonna minus 3x from both sides for people who like doing it that way. That cancels, and I have 2x minus 3x gives me -1x equals 3. And when you have -x equals 3, you might as well change that into x equals -3. So this negative sign just jumps there, because basically this is a -1, and if you divide both sides by -1, you get x equals -3. Okay, so this is basically it. And you know what? We're gonna leave it here today. That's good enough. And I'll see you guys next week, inshallah.